In the case of geometric growth, this is just opposite. Here, from one parental cell, two daughter cells are forming. Two daughter cells are forming. Okay. And in the case of arithmetic growth, we just explained that one cell have the capacity to cell division and another one cell have the capacity to cell differentiation. But in the case of geometric growth, here from one parental cell, two daughter cells are forming. And both the daughter cells having the capacity to cell division. Cell division. So from here, one cell is dividing into two, and again this cell, the first daughter cell is dividing into two, and also the second one daughter cell is dividing into two. Then 1, 2, 4. Then it is these both cells have the capacity to cell division, and here it is forming 4 new cells, and here also it is forming 4 new cells. So we can say that it is 8, and then 16, 32, 64, like that. It is increasing. It is geometric. Okay, and when we are applying this geometric growth into a graph, we are getting a sigmoid curve. Sigmoid curve. We just already explained this arithmetic and geometric or logistic or exponential growth in organism and population chapter. So, and we know that when the resources are unlimited or limited, the graph may be changed. In the case of geometric growth, here it is resources are limited. So, first upon one log phase. In first stage, we can say that one cell is dividing into 2, then it is into 4, then it is into 8. At that time, we can say that in first stage, this is the slow growth. One cell is dividing into 2, then 2 is into 4, like that. So we can say that first one stage is log phase. Okay, and the next one stage, this is the exponential growth stage. The maximum growth is happening in this stage. That means 8 cells dividing into 16, 16 into 32, 32 into 64. It is very high range. So we can say that it is the log phase. The maximum growth is happening in this stage. And the last, when its resources are limited, at that cases, one stationary phase is occurring. Stationary phase. Here is no more growth is happening. It is going into a stationary phase. So in geometric growth rate, when we are putting it into a graph, here we are getting a J-shaped curve. Here we are getting a J-shaped curve. In that curve, we can see that there are 3 phases are there: log phase, log phase, and stationary phase. In log phase, we can say that it is a first one stage. It is very slow process, and next one is log phase. It is high concentration, higher growth rate is happening in this stage, and when the resources are limited condition, at that time the growth is only in stationary. The growth is stable condition here. So we are getting a J-shaped curve, and in arithmetic we are getting a linear curve. In every division we are getting a two new cells, and one cell have the capacity to division, and another cell getting the capacity to cell differentiation. This is the geometric and arithmetic growth rates. And here also one equation is there for this geometric